Okay, we're going to have a look at partial fractions. There's 3 videos to this. The first one is dealing with it on a simple level. So we're going to have a look at some fairly complicated algebraic fractions, and we're going to simplify them. And that's what partial fractions does. And the principle goes a little bit like this. I'll do a numeric one. So if I had a fraction like 8 over 35, it's a little bit complicated, but I know I could write it as 2 simpler fractions added together. And because I've got a 35 here, I could have something over 7 and something over 5. All I would have to do is to work out what the numerators are. So let's make a start on an algebraic one. So 6x minus 2 over x minus 3x plus 1. The denominator is already written in factorised form, which helps me hugely. If it isn't, then put it into factorised form. Now I know that I can write that as 2 fractions added together, where this one is something over x minus 3 and this one is something over x plus 1. And that's an A and that's a B. So I know it's going to look something like that. I've just got to work out what A and B are. Alright, looking at this, let's write that as 1 fraction. And just reversing the process that we did here, to add 2 fractions together, as you know, multiply that, multiply those 2 and multiply the bottom one. So we know the bottom number, the denominator is going to be x minus 3 times x plus 1, just as in our question. The top, the numerator, is going to be a times x plus 1 plus b times x minus 3. And we know that this numerator must be the same as that numerator. I could multiply it out, might make life a little bit easier for me in a while. Plus a minus 3b over x minus 3 times x plus 1. So I've set it all out. I just know that this has to be the same as that. There are 2 ways of working it out. One uses this form and one uses this form. So first method for working out A and B. We're going to equate the coefficients. I know that over here there are 6 x's. So I know that ax plus bx must equal 6x. So therefore a plus b has to equal 6. But I also know that a minus 3b has to be minus 2. So a minus 3b has to be minus 2. I now have 2 equations, 2 unknowns, and I can quite easily sort out what A and B are using Year 10, Year 11 simultaneous equations. I'm going to label that number 1, number 2. I'm going to eliminate by doing equation 1, take away equation 2. The A's cancel. B take minus 3b is 4b. 6 take minus 2 is 8, so 4b equals 8 and b is therefore 2. Once I know that b is 2, put it back into one of these 2 equations, presumably the easier one. Put it back into here, a plus 2 equals 6, so a is therefore 4. And we've worked out what A and B are, so I can now rewrite this as 4 over x minus 3 plus 2 over x plus 1. I've now simplified that algebraic fraction into these 2. If I wanted to differentiate this or integrate it as it is, that would be very tricky. If I rewrite it as 2 simpler ones, that makes life a lot easier. The second method for working out what A and B are is to look at this version here and substitute in some values. I'm going to substitute in values of x here that make a disappear, and then I'm going to substitute values of x that makes b disappear. That way I can work out what A and B are. So let's substitute in here x is minus 1. That will make this thing 0. So x equals minus 1. So I have got 0a plus minus 1 minus 3 is minus 4b. So I've got minus 4b And that has to be the same as whatever this thing is if I substitute x is minus 1 in. So if x is minus 1 over here, 6 times minus 1 is minus 6, minus 2 is minus 8. So if minus 4b is minus 8, then b has to be 2. I'm then going to do the same thing over here, substitute a value of x in, which makes this thing 0. That will be x is 3, so put x is 3 in. This is going to be 0b. If x is 3 over here, I've got 3 plus 1, which is 4a, and that has to equal whatever this thing is, if x is 3. 6 3s are 18, take 2 is 16, so a is therefore 4. And those two answers, obviously same as those two answers. That's how you rewrite a complicated fraction as two simpler fractions. That's called partial fractions.